Hello, and welcome to Algebra 2, Lesson 2.5. So we're going to keep going with quadratic equations, which are our parabolas, and we're going to now look at different ways the formula is written out to help us graph it. So the first thing we're going to look at is something called vertex form, which we should be somewhat familiar because we saw it in the absolute value. So the vertex form of a quadratic equation or function is f of x equals a x minus h squared plus k. Right? So your vertex is the same thing like that absolute value one, h and k, so the opposite of what happens to x and whatever k is. Okay? And x equals h is the axis of symmetry, meaning that when we graph it, the middle of our parabola is always whatever h is for the x coordinate. All right, and a, that's going to determine the width and the direction of the parabola. All right, so why use this form? Well, so the vertex form obviously shows us, the vertex of a parabola, which helps us graph it. So, and remember that this is in respect to the parent function, which is, f of x equals x squared, where the vertex would be right here at the origin, and it's being moved based on what happens. All right, so let's go ahead and try some of these. Now, on number one, we're going to kind of describe what is happening to our parabola. Up left, up right, down, 4 over, 2 up. So basically, when we look here, we see nothing is happening to x. So that gives us our x is 0. Right? And this one says we're going to go up 9. So that makes our vertex 0, 9. So this is just up 9. All right, when I look at number 2, I see that nothing's happening to x, and I have a negative 2. Now, don't think that this plus 9 is affecting the x. Things that affect the x are going to be in parentheses, such as x minus 2 squared. This is affecting the x. Okay, so it has to be in a parenthesis to affect the x. So the x is staying the same, and we're going down 2 in the y. So 0, negative 2 is my parabola. All right, next thing we got is f of x equals negative x plus 5 squared. Now notice there's nothing hanging out on this side, and this is affecting the x. Now remember, we go opposite. When we add to x, we go left. So we're going left 5, okay? And now when we have a negative here, it's also going to be flipped or reflected. So same thing. So this will make my vertex negative 5, 0. All right? And for 4, 5, and 6, especially with 5 and 6, put these in Desmos.com and you tell me how that looks. To compare, to describe what happens when we have these numbers in front. It's similar to what's going on with our absolute value function, but not quite exactly the same. Right, so number 7 says Mason graphed the parent function of a quadratic equation. Then he reflected the parabola over the x-axis and translated it, which means slide, 7 units up and 3 units to the right. What is the equation of the new parabola? Well, when he reflects it, that means we're going to have a negative sign in front. And when it says that he translated it up 7 units and 3 units to the right. So remember, when we add to x, we go left. So that means we're going to have to subtract from x to go right. So basically, we're just going to do our x minus 3 squared. And then when we go up 7 units, we do plus 7. So this would be our equation. f of x equals negative x minus 3 squared plus 7. I got the minus 3 because that means I'm going 3 to the right. and the plus 7 means I'm going up, and the negative sign means it's reflected or flipped over. Right, so give the vertex and the axis of symmetry for each function or inequality, then graph it. Well, we see here that the x, okay, is -2. So that means our vertex is located at 2, 3. So we have 2 and then 3 right there. We know it's going to be right side up, and our axis of symmetry is going to be x equals 2, because this is going to be the middle of our parabola. So we can start with 2, 3, right? And we can go ahead and put some points in here to see how it works, right? So let's go with 1, 0, 3, 4, and I guess we'll go -1 and 5. So if I put a 1 in here, 1 minus 2 squared plus 3. 1 minus 2 is -1 squared plus 3. This is 1 plus 3 is 4. So that's my 4. All right, let's go ahead and try 0. 0 minus 2 squared, well, that's -2 squared plus 3 is just going to be 4 plus 3 is 7. So now that'll be 7. -1, x minus a -1, -1 minus 2 squared is -3, all squared, and that's always plus 3. So that's 9 plus 3 is 12. All right, so that's how that one works. If we did the other side, we're going to get the same answers. If we use 3, it'll be 3 minus 2 squared plus 3. 3 minus 2 is 1 squared plus 3 is just 4. And we do this, it'll be 7, and this one will be 12. So now we can graph it. We already have our 2, 3. So we have a 1, 4. We have a 0, 7. And we'd have a -1, 12 all the way up here. And it's the same thing on the other side. All right, so that's how that one is graphed. I'll let you guys tackle number 9. Let's go to 11. All right, so now on 11, I see that I have a number in front, which isn't a big deal, but I see that it's x minus 4. So that means my vertex is at 4 for the x, and there's nothing going on over here, so this is just a 0. So I know right here that I'm at 4, 0. All right, so now I see I have a 3 in front as a coefficient, so we'll see what happens here. So I have a 4, 0, and my axis of symmetry is going to be x equals 4. And now I'll use different values, 3, 2, 1, 5, 6, 7. If I use 3, that's 3 times 3 minus 4 squared. Well, 3 times a -1 squared. -1 squared is 1, so 3 times 1 is 3. Let's try the next one. 3 times 2 minus 4 squared. 3 times -2 squared. So 3 times 4 is 12. All right, so now when I have 1, it's 3 times 1 minus 4 squared, 3 times -3 squared, so 3 times 9 is 27. So you see how this is getting pretty big pretty fast. So 5 would be 3 times 5 minus 4 squared. 3 times 1 squared is just 3. And this will be 12, and this will be 27. It's going to have the same pattern. So now I have 3, 3, which is right there. I have 2, 12, which will be all the way somewhere up here. And 127 might be right there. And on the other side, the same thing is happening. And if you notice from graphing your other ones on the calculator, on Desmos, like I said, you'll notice that when this number is bigger, greater than 1, the parabola gets very narrow. When it's less than 1, then it gets wider. All right, let's go ahead and do let's do 13. All right. So now, when I look at 13, this is another piecewise function. All right, and this is telling me when x is less than or equal to 1. So if I zoom in on this, here's 1. Right, and let's make this one our purple one or our pink one. We'll make this one our green one on this side. Now, if you look, see how this has the equal sign? So when I get to 1, I'm going to have a solid circle. When I get to 1 with the green one, I'm going to have an open circle. So let's go ahead and graph this. This says negative 2x squared plus 6. Right? So what happens is that we have to go ahead and we have to graph this. Now, how would you graph this? Well, it's not in vertex form, so we just kind of have to use our table to do this. All right? Because what's going to happen is that we're going to learn how to move it into vertex form, but we're not quite there yet. All right, so let's go ahead and see this. This one here, we have to use x is less than or equal to 1. So that means I'm going to use numbers less than 1. So like 1, 0, negative 1, 2, 3, things like that. And that's my x. And actually, I should do this in my purple. So I have 1, 0, negative 1, 2, 3. There's my x. Here's my y. And I'm at negative 2x squared plus 6. So that gives me negative 2 times 1 squared plus 6. Right? So negative 2 times 1 plus 6. This is negative 2 plus 6 is just a positive 4. So my first point is 1, 4, which is right here. And I'm going to get a solid circle because you see I'm solid there. 0, negative 2 times 0 squared, well, that is 0 plus 6 is just going to be 6. So I'm at 0, 6 is my next one. Right there. Oops, I made a nope, I'm right. Okay. And then my next one is negative 2 times a negative 1 squared plus 6. So remember, this is negative 2 times 1 plus 6. So this will give me a negative 2 plus 6 is 4. So I'm at negative 1, 4. So right there. 2 will be negative 2 times 2 squared plus 6. Negative 2 times 4 plus 6. So negative 2 times 4 is negative 8 plus 6 is a negative 2. So that'll put me right here at 2, negative 2. And then finally, negative 2 times 3 squared plus 6. Well, negative 2 times 9 plus 6 is negative 18 plus 6, which is a negative 12. So 3, negative 12 would be my next point, which would be somewhere over here. So we see that our parabola is doing one of these. All right. So now we have to graph our other one, which is this one, which you can graph in the y equals mx plus b form. We'll do that in green. It says that my y-intercept is 4. Okay, I'm just putting that there for right now. And then I'm going down 3 and over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. So now I have to get rid of this one green one because it was in purple's territory. And then I graph my green line like this. All right, so that's how that one is done. All right, let's go ahead and look at 15 now. So on 15, this is in vertex form. So we can see that our vertex, right, is going to be negative 1, 7. So that's a negative 1, 7. So we can go graph that negative 1, 7 right there. All right. Now, we go ahead and we graph the rest. All right, so now I'm going to have a -2, -3, -4, 0, 1, and 2. So if I use my -2, 4 times -2 plus 1, all squared, minus 7. 4 times -1 squared minus 7. So 4 times 1 minus 7. 4 times 1 is 4, minus 7 gives me a -3. So that's a -3. So I have, put that on the wrong side. So I have -2, -3. So -2, -3 is right there. All right, so let's try -3. 4 times -3 plus 1 squared minus 7. 4 times -3 plus 1 is a -2 squared minus 7. 4 times 4 minus 7. So 16 minus 7 is 11. All right, so 16 minus 7 is 11. So -3, positive 11. So that's going to be all the way, probably about there. All right, now let's go to the other side, since we're off the graph already. 0. 4 times 0 plus 1 squared. 4 times 1 squared, of course, minus 7. So 4 minus 7 is a -3. So that's my -3, 0, -3, right there. Right, when I put a 1 in, I'm also going to get 11. We can try it again. 4 times 1 plus 1 squared minus 7. 4 times 2 squared minus 7. 4 times 4, which is 16 minus 7, is 11. So to 11, also going to be all the way up there. So this is what this one is going to look like. And the reason I'm doing it like this, if you notice, this is not an equal sign. It's greater than or equal. So it gets that solid line. Now, if it's greater than, it just means that it's in the parabola, okay, but on top. If it was less than, it would be outside the parabola, when a parabola is facing up like that. All right. I also noticed I just made an arithmetic mistake, because I do that a lot. This over here, where this -3 is, 16 minus 7 is actually 9, not 11. So it should be 9. I noticed that when I was just staring at it for a second. So that'll be 9. That'll be 9. So that would be like right there. All right. Just when I looked at it, I noticed it just didn't look right. All right, so just be careful with that. All right, so the rest of them I'll have you do in class. And if you have any questions, you can go ahead and ask me. All right, so for people hanging around, here we go with the other ones that we didn't do. Right, so when we look at this, right, so we see here we're -4, so that's a +4 minus 1. That's going to be our vertex. So we can say this is 4 right, 1 down. All right. When we go to 5, let's worry about that 1/3 later. Right now we just have a +2, but nothing with the x in parentheses. So it's going to be 0, 2. So 2 right, 2 up. And this 1/3, right, that just means that it's going to be a reduction or a compression by a third. So it's going to get wider, believe it or not, because it's going to push down on top, and we're going to see that. All right, the -2 means that it is reflected, and it has an expansion by 2, and the +4 means we're going to go 4 left, and then we're just going 4 left, and that would put our vertex at -4, 0. All right, so on number 9, our vertex is just going to be 0, -4. Our axis of symmetry will be x equals 0, or the y-axis. All right, so now we can go ahead and we can put this -4. We can go -1, negative 2, negative 3, 1, 2, and 3. When we go and we put this in, negative 1 squared minus 4. Negative 1 squared is 1 minus 4, which is negative 3. So that gives us a negative 3. This would be a negative 3. If we try the negative 2, negative 2 squared is 4 minus 4 is 0. So that's going to be a 0, and that would be a 0. And we'll see when we plug that in, this is a 5, and this is a 5. So we can graph this. We have negative 3, 5, negative 2, 0, negative 1, 3, 0, negative 4, and it's the exact same on the opposite side. So this is the way our parabola is going to look. All right, so for number 10, all right, we're going to be flipped, obviously, but our vertex is going to be negative 5, negative 1, and our axis of symmetry is, we'll call that AS, axis of symmetry, is going to be x equals negative 5. So we have negative 5, negative 1. So we're going to do points around it, negative 6, negative 7, negative 8, negative 4, negative 3, negative 2. When we go ahead and we do it and we plug it in, negative, let's do negative 6 plus 5 squared minus 1. Well, negative 6 plus 5, that's a negative 1 squared minus 1. So negative 1 squared is just 1 minus 1. So negative 1 minus 1 is negative 2. All right, let's try negative 7. Negative 7 plus 5. You can use calculators for this too. Just type it in exactly like this. Right, negative 7. Negative 7 plus 5 is a negative 2 squared minus 1. So negative 4 minus 1 is negative 5. So we're at negative 5. And this is going to repeat the same on the other side. And this one will come out to negative 10. So we can go ahead and graph this. We have a negative 8, negative 10, all the way kind of like right there. Then we have a negative 7, negative 5. So that would be right there. Negative 6, negative 2. Negative 5, negative 1. Negative 4, negative 2. Negative 3, negative 5. And then finally over here. So this parabola is going to look like this. All right, so now number 12 is another piecewise function. I'm going to go ahead and erase this. I'm going to once again use my colors to help me out here. Right, now this first one, this blue one, right, that tells me that x is less than negative 2. So less than negative 2 is right there. That's negative 2. And that tells me my green one's going to have an open circle. So that means this one's going to be on this side. The blue one, which is greater than negative 2, is going to be on that side. And guess what? It also has an open circle. So it's never actually going to be defined at negative 2. So we can go ahead and graph this green one just like normal because we're in y equals mx plus b. So we go down to negative 6, which is right there. And our slope is negative 1 down 2. Negative 1 down 2 to the right, like that. But that doesn't help us. We need to go the other way. So we go this way. Up 1, 2 to the right. We have to put an open circle. Up 1, 2 to the right. Up 1, 2 to the right. So our line is going to go this way. And we have to erase any green dots that are in the blue area. Now to graph our blue one, we need to make our table of values. So we have our x minus 1 squared minus 5. And our table of values should be greater than negative 2. So we're going to have negative 2, negative 1, and 0, and let's do 1. So this would be negative 2. Make this bigger. This will give us a negative 2 minus 1 all squared minus 5. Negative 2 minus 1 is negative 3 squared minus 5, which is 9 minus 5, which is 4. All right, so that's that one. Then I have a negative 1 minus 1 squared minus 5. Negative 1 minus 1 is a negative 2 squared minus 5, which is 4 minus 5, which is a negative 1. All right, then I have 0 minus 1 squared, which is negative 1 squared, which is just 1, and all minus 5. So 1 minus 5 is a negative 4. And then finally, I have the 1, which will be 1 minus 1, which is 0 squared, which is 0, minus 5 is negative 5. So those are my values. So I am at a negative 2, 4. Now on negative 2, 4, I have to have an open circle because I don't have anywhere where it has a line underneath. So I'm not allowed to do that. Then I have negative 1, 1. I have 0, negative 4. And then I have 1, negative 5, which is right there. So this is kind of the way that, oops. Let me fix that. So it's going to be like kind of going like this. Right, I think I made a mistake. Let's see. Nope, I definitely made a mistake with this because this should be right side up. So where did I go wrong is the question. So negative 2 minus 1 is negative 3. 9 minus 5 is a positive 4. That's what it is. That's where I'm wrong. It's negative 2 positive 4 right there. All right, so now that we're on the right track. Then it's negative 1, negative 1, which is right there. 0, negative 4, which is right there. You see when things don't look right, you just go back and you see what's going on. Then we have 1, negative 5, which is right here. Now what happens is that you notice that my vertex is negative 1 is going to be 1, negative 5, which is this one right here. The problem is I need more points on this side, but we know it's just going to reflect over this way. So we're kind of safe because we can predict what our parabola is going to do because it's always mirrored because this is the line of symmetry right here. All right, and then we got 14. So on 14, this is an inequality again, and notice there is no line under here, so we're going to have a dashed parabola. Okay, very important, a dashed parabola. Our vertex is going to be 3, 0. So 3, 0 is our vertex. So we're going to go 2, 1, and let's do 4 and 5. Okay, these points, you really don't have to go 7 points. 5 points is enough. So now what I'm going to do is I have negative 2 minus 3 squared. So it's negative 1 squared. So negative 1 squared is 1, so just negative 1. So 2, negative 1. So 2, negative 1 right there. All right, now if I have 1, negative 1 minus 3 is a negative 2. So I have a negative 2 squared, which is 4. Negative 4 is my answer. So now I have a 1, negative 4. So right there. And that should be good enough for that one. If I do the 4, negative 4 minus 3, 4 minus 3 is 1. 1 squared is 1, so I get that negative 1 again. Right? So it's just going to follow this pattern. So your parabola has to be dashed because it doesn't have that equal sign. And now where to shade it, right? So now, see how this is less than, but this parabola is facing down, so it has to be under the parabola. So that's where we're less than. So it's under the parabola, which would be that area. If you think of greater than, that would be bigger than the area. All right, so if you have any questions or concerns, let me know and set up an office appointment. Have a good one.